Hello everybody, welcome to your second assembly language tutorial. In this video we are going to discuss registers. So what are registers? Registers usually consist of a small amount of fast storage. A register can hold an instruction, a storage address, or any kind of data. So there are different kinds of registers. A few we are going to discuss include general purpose registers, segment registers, the flag register and the instruction pointer. So let's start with general purpose registers. There are 8 32-bit general purpose registers, and of those 8, 4 of them can be further divided. For example, the lower 8 bits of the EAX register can be called AL register, and the upper 8 bits can be called AH register. If you combine both these 8-bit registers you get a 16-bit register called AX register. Similarly, EBX, ECX, EDX registers can be further divided. Let's take a look at these registers one by one. First we have EAX register, also known as the accumulator register. It is used in arithmetic instructions. Well, what does that mean? The accumulator register is always used as the multiplicand or the dividend. Let's take a look at this with an example. So we have an example here, where the first line of code moves the value 4 into AL register. Similarly, the second line moves the value 5 into BL register. Now the third line takes whatever the value is of AL register, multiplies it with BL register, and stores the result in AX register. In the same manner the division is also done. Next we have base register. So in this example here there is a variable x, which has value of 1, and we assume that it is placed at address 01234. The first line of code moves the address of the variable x in EBX register, and the second line moves the value at the address into register AL, getting the reference to the effective address, and then getting data from that address is also known as indexed addressing. Next we have the count register. The ECX register is used by loop instruction to store the loop count. The value of ECX determines how many times a loop will repeat a sequence of instructions. Next we have the data register, which is used with accumulator register for multiply and divide operations involving large values. Let's see what that actually means with an example. The first two instructions moves the values 1234 and 5678 into AX and BX registers respectively. The third instruction takes the value of BX register and multiplies it with AX register, and then stores the first half of the result in DX and second half in AX register. So if you combine the values of DX and AX register you get the right result, which is 7006652. Next we have the source index and the destination index register. Both the registers are used by string instructions. So the code here moves the address of the variable in the ESI register, adds 1 to that address, and gets the character at that address, which is O. Next we have the stack pointer and the base pointer. The stack pointer points to the top of the stack, while the base pointer points to top of the stack with respect to a procedure. In a later video I will explain exactly what that means. Although I have prepared an example for stack and base pointer as well, we will skip it for now. We will take a look at stack and base pointer in detail in later videos. If you guys didn't understand the code in this video, don't worry about it. It was just used to give you guys a rough understanding of how the code is written, and how each of the registers are used. If you guys liked the video please press the like button below and subscribe to my channel. Until next time, Hawk out.